Hi and welcome to this tutorial on redox processes. So in the previous tutorial, we learned about what those are and we learned about redox in general and how to assign our oxidation numbers and identify redox reactions. So here we're going to have a look in a little bit more detail and also at disproportionation reactions as well. So a reminder that redox reaction is both when we've got reduction and oxidation happening at the same time. So in redox reactions, we have the transfer of electrons between two species. So the electron donor is going to be oxidized and the electron recipient is going to be reduced. So oil rig is a useful acronym that you might want to use in these reactions. Let's have a look at an example then. So a typical example of a redox is the reaction between a metal and an acid to form a salt. So if we have a look at the reaction between sodium metal and hydrochloric acid. So sodium metal, so 2Na and 2HCl. So you're going to get 2NaCl and H2, and of course that's a gas. And the equation, we can write this out as an ionic equation in which the compounds that are in an aqueous solution dissociate. Only the compounds that are in an aqueous solution. So the sodium, because it's solid, a metal, that's going to stay as it is, but HCl is going to dissociate. Now I've got two H's and two Cl's. So I've got 2H plus 2Cl minus, and it's going to give us 2Na plus because sodium chloride is soluble, and 2Cl minus, and H2 because that's gaseous, so that's not going to dissociate. So I'm only dissociating NaCl and HCl. Okay, so having a look at this slide, so I've written it out more clearly here, we can see that the chloride ions have remained unchanged before and after the reaction. They're said to be spectator ions. They do not take part in the chemical reaction because they remain unchanged, but we can tell because their oxidation state has also remained unchanged. So we cancel them out, and then we're going to rewrite our equation out again without the chloride ions, and that's our ionic equation that we have here. So let's now have a look at the oxidation numbers of the elements that are involved. So we're looking at our hydrogen, H+, that's in group 1, and therefore its ion is a plus, so therefore it's a +1. Remember I said before, oxidation numbers, I always remember that there's an X there, and that looks like a plus on its side. That reminds me that when I'm giving oxidation numbers, I always have to put the plus first, the plus or the minus first, and the number afterwards. Whereas with ionic charges, we do it the opposite way round. We do 2+, we put the number first. It's really important that you don't muddle this up. You will lose marks in the exam. So it's +1. And then we are going on the other side to 0 because the hydrogen's in a compound here, a neutral compound, so it's 0. That is a reduction. We're going down the number line. So from 1 down to 0. So therefore hydrogen has been reduced. Looking at sodium, solid sodium is going to be 0. And then it's an ion on the other side. And it's going to therefore just take its ion charge. So +1. So that's gone from 0 up to +1. Therefore it's been oxidized. It's increased in its oxidation number. Then we've got disproportionation reactions. So this is where a single species in a chemical reaction is simultaneously oxidized and reduced. So for example here, we've got dilute chlorine reacting with a dilute alkali, and some chlorine atoms are reduced and some are oxidized. Let's actually put numbers to this. So we start off with 0 for the chlorine because it's in a compound by itself. And then over here, we're going to end up with -1 because sodium is +1. Chlorine therefore has to be -1 to get us back to 0. And then in this compound here, we could do a little bit of algebra just to check. We know the whole compound is a neutral, so it's going to be equal to 0. And I know that sodium's in group 1, so it has to be +1. So 1 plus Cl, that's the one I don't know, plus, it's not an exception for oxygen. It's not a peroxide and it's not bonded with fluorine. Therefore, oxygen is going to take a -2 charge, so -2, and there's only one of them, and so I'm going to solve this for chlorine. Okay, so if I solve that for chlorine, then I'm going to get +1. So chlorine has an oxidation state of +1 here. So we can see that chlorine has been reduced in this case, and then it's been oxidized here. We've gone up the number line there, so it's been both oxidized and reduced.